Hello everyone. So in this session we are going to see NSEJS questionnaires. So NSEJ is nothing but National Standard Examination in Junior Science. So we have seen about the intro of the NSEJS. Now we go into the questionnaires. So the first question of today's session. A particle initially at rest at origin starts moving under acceleration A along positive x direction. The acceleration versus time graph is shown in the given figure. So displacement and the velocity of a particle after 6 seconds they are asking. So this is the given question. So let me zoom it out. Yes. Is this visible? No? No. Yes, fine. Is it visible? Good. Now what the thing they have told. So here if I see a time is from 0 to 3 seconds, 3 seconds to 5 seconds and 5 seconds to 6 seconds. So we'll take the time periods of 3 cases now. Okay. So how much it is? 0 to case 1, 0 to 3 seconds right now. And case 2 if I see 3 to 5 seconds, and case 3 if I see 5 seconds to 6 seconds. Okay, 3 cases I will take. So what is the time taken in case 1? It is 3 seconds. What is time taken in case 2? It is 2 seconds. What is time taken in case 3? It is only 1 second. Right? No? So these are the things. So for the case 1 I need to find the velocity as well as the displacement of the particle. And one more thing they have told, a particle initially at rest. So initially at rest in the sense, for the case 1 u will be equals to 0. Okay, u will be equals to 0. But for the case 2, whatever velocity we are getting for the case 1, that velocity I should take it as u. Fine, right? So here what will happen? V is equals to u plus at. Okay, so v1 I'll consider velocity of the case 1. So what is the acceleration? It is 4 meter per second square it is maintaining, and if I mean 4 meter per second square, yeah, right, and the time is 3 seconds. No, so it is 0 plus 4 into 3, which is nothing but 12 meter per second. This is my velocity. What about the displacement? Displacement S is equals to ut plus of at square. Can I use this equation to find the displacement? Right now, and v square minus u square equals to 2as. In that also I can find the, yes, where v is nothing but 12 and u is nothing but 0. Right now, yeah. Let me give that equation also to find it. Okay, so first we'll find here. So this is 0, we can neglect it out, and 1 by 2. What is the acceleration? It is 4 and time is 3 square. Right now, so this is 1 times and this is 2 times. So it is 2 into 9, which is nothing but 18 meter. So this is my speed and this is my, this is my velocity and this is my displacement of the case 1. Okay. Now I told you that v square minus u square is equals to 2as. From this also I can find it by using v, that is final velocity. So it is 12 and u is 0 and acceleration is there. So from this also I can find the displacement of the given particle. Okay. So next is case 2. Case 1 is completed. We'll go for the case 2 now. So when I see the case 2, there is no acceleration. Acceleration is 0. I'll write it here. Case 2, acceleration is 0, which means, constant velocity, right? Constant velocity. So constant velocity in the sense, whatever velocity we got for the case 1, the same velocity going to be continued, right? So v2 will be equals to 12 meter per second. 12 meter per second, right? Na? So what is the what is the displacement? Yeah, displacement S is equals to S2 will be equals to ut plus half at square, right? Na? Ut plus half at square, where a is 0, I can neglect this term totally. And what is u? It is 12. And what is the time taken here? Time taken is 2 seconds, right? 2 seconds. So into 2, which is nothing but 24 meter. This is for the case 2. What about the case 3? Case 3. So what is the velocity here? 12 meter per second, no? So initial velocity. So it is V2, I'll consider here V2, okay? 12 meter per second, which is nothing but the U for case 3, okay? And I need to find V3 is equals to U plus AT, where U is nothing but 12 plus, what about A here? A is minus 6 and time is 1 second, okay? So A is minus 6 and time is 1, which is nothing but 12 minus 6 is equals to 6 meter per second. What about the displacement? Displacement is S3 should be equals to ut plus of at square. This is the formula, but what I should use here? U as 12, right? No, U as 12 and of at square. 12 into what is the time? 1 second only, no? Yeah, plus 1 by 2 into minus 6 into 1 square, which is nothing but 12 plus 1 by 2 into minus, yeah, I can write this as minus 3, which is equals to 9 meter. So what is the total displacement? Total displacement is nothing but S1 plus S2 plus S3. So what is the answer? 9, 24 and then what it is? 18. 18 plus 24 plus 9. So it is 32, 32, 42 and 51. Yes, na? So 51 meter. So let me check the options now. So they have asked displacement and velocity. So 51 and what is the final velocity? It is 6 meter per second. So option A is the answer, right now? Option A is the answer. Yeah, you can cross verify it, whatever answer you got it. This is about case 1. This is for the case 1 totally. I have written here, given the arrow mark also. Only for the case 1 we have done here. For the case 2, the next slide is there, okay? You can note this one. We'll go for the next one. Yeah, next slide. Done, right? You have cross verified the answer. Okay. So the next question is, yeah, little bit I'll zoom it out. Is it fine? Yeah, thank you. A particle of mass 0.3 kg. I will write down whatever given here. So particle of mass 0.3 kg starts moving from rest. So u is equals to 0 in one dimension under a force that delivers constant power. Okay, so power is equals to 1.5 watt. So it is constant. Okay, write the thing. And the kinetic energy of a particle will be kinetic energy of a particle is 15 joules after a time of, okay, they are asking what is the kinetic energy of a particle will be 15 joules after a time of, how much time it has been taken. Yeah, we know that power is nothing but the rate of work done, right? So P is equals to work done by time. I can write this as like rate of work done. Here the energy is changing with respect to time, right? So I can say that P is equals to D kinetic energy by dt, right? No? And we know that I can write this formula as Pt is equals to kinetic energy, which is nothing but work done is equals to power into time when force is constant. When force is constant, right? No, I can use this, but as of now the thing is P is equals to d kinetic energy of dt right now. And one more thing, we know that power is equals to force into velocity. So these are the things. So now take this equation now, like it's changing now. So dt, P into dt is equals to d kinetic energy, right? Kinetic energy. So what is the kinetic energy formula? Kinetic energy is equals to of mv square, right? No, so from this I can do it easily, no? Yes. Yeah, so yeah, no need to worry this one, like the same thing we have written. No, power is equals to like kinetic energy of mv square by t, right? No, yeah, from that only we have got it, right? No, so I can write this as 1 by 2 mass into velocity by time. Yes, na, velocity into velocity by time. Here what we have taken, change in kinetic energy with respect to time, na. So P is equals to d v by dt. One thing I can take from the previous formula, I have written the formula like this: mass into velocity by time. So dv by dt I have taken here, and mass into velocity I will take. Okay, no. Now take this dt to the other side. P into dt is equals to mass into velocity into dv. Okay. Now say that, like if you see that, no, like it is changing from time and velocity also changing, right? No, so integral 0 to t p into dt is equals to integral 0 to v m I will take commonly out, constant outside, no, yeah, is equals to m into integral 0 to v dv. Okay, that's it. So from this, yes, we are going to get the same thing. Yeah, where is the next slide? I will take. Okay, fine. So it is p dt, no, dt with respect to 0 to t integral. So into t I will get is equals to m into v square by 2. That's it. So kinetic energy we got now. Now we got the same thing. So now I can equate it. Now I can say Pt is equals to kinetic energy. So where P is nothing but, how much it is? P is nothing but 1.5 watt and kinetic energy is 15 joules. So Pt is equals to kinetic energy. Kinetic energy is 15 joules and it is 1.5. So 15 into 10 divided by 15, which is nothing but 10. Answer is 10. 10 second is the answer. That's it. This is the answer for the given question. Can we see the next question? Okay. Yeah, is it visible now? Fine. A trolley of mass 200 kg carrying a sandbag of mass 20 kg is moving on a frictionless horizontal track with a speed of 36 km per hour. Okay. After a while, sand starts leaking out of the bag on the floor of the trolley at the rate of 0.04 kg per second. What is the speed of a trolley after the entire sandbag is empty? See, keep in mind that, like when you are seeing the question here, no, there is a trolley which is carrying a sandbag. So there is a trolley, okay, which is of mass 200 kg and one more sandbag is there inside the trolley which is of mass 20 kg, right? No, is moving on a frictionless horizontal surface. Okay, it is no friction. Okay, no friction here. And with the speed of, so going with the speed of v is equals to 36 kilometer per hour. Okay, per hour. So what I should take here, I should take it is in meter per second first. How much it is? So 36 into 5 by 18, which is nothing but once and twice is nothing but 10 meter per second. Going with 10 meter per second. That's it. Now if the sand is leaking, no, where it will go? Sand will go. This is the trolley. Inside a bag is there. If something is leakage happens inside the bag, what will happen? It will be inside the bag only. There is no change in mass, right? No, there is no change in mass, and there is no external force also applied here. So momentum will be same. Momentum will be same. Which momentum will be same means same velocity. So option C is the answer. Here the thing is, it is leaking. Okay, whether it's leaking inside or outside, it's going inside or I mean it's getting inside only or it's going outside. That thing I should check there. Okay, if it is going outside, mass is reducing and velocity will be increased. Right now, here mass is not changing, 200 kg and 20 kg. So it is same. It is not changing. So there is no change in mass. There is no change in velocity. So velocity will be 100 meter per second. That's it. Okay. So with this we'll end this session and we'll see some more question in the next session. Thank you guys.